Today, we're in section 5.4. We're going to define and use the inverse function. So this is almost no different than the cosine function inverse. So it's going to sound very familiar, and many of you will already be able to do this without my help. All right, so in terms of warm-up, giving the measure of an acute angle, so that's the key situation, whose sine is equal to radical 3 over 2. Well, before I can do that, I need to know what radical 3 over 2 is equal to. So punch that in my calculator to get 0.866, etc. And if I wanted to see where that is, 0.866, let's see here. Notice that I'm going along the curve here, and somewhere about there's 0.866-ish, right there is the closest I can get. So notice it's 1.04, and this is a radian. So when I check, so 0.866 is going to yield to me 1.02 radians. All I have to do, of course, is convert that to decimals. Remember, to convert, I'm going to say 180 degrees over pi radians. So I just plug that into my calculator, multiply that, and divide by pi. Approximately 58.4 degrees. And now to check an obtuse angle that is equal to the same. Notice that when I check this, obtuse angle would be somewhere over here because 50s would be there. So all you have to do essentially is just add a little bit to it. But let me see, 0.866 is right there, which is slightly over 2 radians, which is going to be in the obtuse area. So once I do that, 0.866 puts me here, which gives me a 2.11-ish. 866, that's the closest, 2.09. So 2.09 radians. And I'll do the exact same thing, multiplied by 180 divided by pi. And the measure of an angle whose sine is equal to 1. So I just find the sine 1, and of course, sine 1 is right there. Or sine of 1, or sine is equal to 1, sorry. Sine is equal to 1. And there we go. And then, of course, do the conversion. Excuse me for that one as well. So today what we're going to spend our time on is looking at the inverse of the sine function. So just by way of making it into a function, I do want to point out to you that we do have to talk about domain just a little bit. We're not going to belabor the point. I just want to point a few things out here. So when we found the inverse of cosine, we limited the domain. And let's highlight what we did here. We focused from 0, and we went to 180 degrees, which is also known as simply pi in radians. So just this section right here. Why did we do just that section right there? Because when I graph that and then compare it to its reflection like that, notice that the blue here passes the vertical line test. So it makes the inverse of the cosine function, it makes it into an actual function. Otherwise, if I were to keep extending it like this, notice now it does not pass the vertical line test. So we have to focus just on a specific part of the domain. So notice this section right here, which is just a squiggle with nothing that comes back on it. So in other words, the crest to a valley, or the crest to a trough. Well, we're going to apply that same idea to the domain of the inverse of sine. So notice here at 0 degrees, or 0 radians, 0 is kind of in the middle of that. Here's a crest, here's a trough. So either I start here and go this direction, or I start in the negatives and come up this way. Well, because this is acute angles right here, we're going to actually include that. So we're only going to do this squiggle right here. Just this squiggle right there. So notice where my domain will have to be. So that one is represented by this part right here. So the inverse of it crosses it and does that. So the diagram overlaps, so it does look a little bit complicated. But notice what our domain is. Our domain is going to start at negative pi over 2, which you could also say negative 90 degrees. And it's going to end at 90 degrees right there. Positive 90 degrees, also known as pi over 2 radians. All right, so we just wanted to point that out, that our domain is limited. Okay, so by definition, the inverse of the sine function says this. We use the -1, sine to the -1, also known as inverse of sine of x, if and only if x is the sine of y, and we're limiting our domain here. We also say arcsine. You will see that. In fact, Desmos itself uses arcsine, as we can see here. If I were to go into the functions there. Functions here, and you see that arcsine is being used there. All right. For each one of these, you're going to do the exact same thing that we've done before with our calculator. All you need to do is plug this in and convert or change the mode on your calculator and then redo the problem. So when I plug that into my calculator, I get negative 60 degrees, which can also be 300 degrees. But for now, since we started with the negative, let's just go ahead and stick with the negative 60 there. And in terms of radians, I get negative 1.047 radians on that one. Good, and then checking our work for the part B there. The next question here, of course, a lot of us plugged this straight into our calculator, and we got that result. Because our calculators happen to be super smart in the sense of they see these two together, and they know they're inverses, so they just cancel it out. But let's try it a different way. In your calculator, please punch this in first. Please punch in sine of 5 pi over 4, then hit enter. So now what we do is we hit the inverse of sine for this one. This brings me to negative 0.7853, which is clearly not the same as this number right there. Because 5 pi over 4 so 5 pi over 4 is outside the focus domain. Outside of the focus domain. So it does need to be only to pi over 2, which is approximately, you could get a decimal on that one. And this decimal is, 3.92. And this decimal here is 1.6-ish or 7-ish. All right, so let's see an application of this. An 18-foot ladder is leaning up against the wall of a house. So I have a house here, and a ladder is leaning up against it. So this is 18 feet long. There's the ground, and we do know that the top of the ladder is 16 feet up. So the question is, what angle does this make? So notice, based on this angle, this is opposite hypotenuse. So it is sine of theta is equal to 16 over 18. And now we can do the inverse of the sine on both sides. So when you plug this into your calculator, you don't even need to simplify. You'll get the result. Since we're talking about angle here in a real life situation, degrees is probably going to be the best result. So I'm going to make sure my calculator's in degrees. And we get approximately 62.7 degrees there. All right, please do example number 4, finding the value of x. Notice that degree is already part of the problem, so you don't have to write your answer with a degree. And in the end here, 55 point what?
0.9.
0.9. Okay, eyes on deck just to follow instructions. Notice I do not need another symbol right there. It already has a symbol down there, x degrees. So if I substituted a degree again in there, it would be degree. So we don't need that. And since it rounded to the nearest tenth, I do a 0.9 there.